Going to go over the Saga pattern. It's going to go through kind of a production kind of level order processing system. So for this order processing system, it's built in Java 17, uses Spring Boot 3.2, and it's going to use the Saga orchestration pattern to handle these different services like inventory, payments, shipping. It's going to have some kind of automatic rollback if anything goes wrong. So we're going to kind of just go through the process of how the system works, the architecture, kind of the code and everything like that. So this is kind of going to break it up into different parts specifically. So for the order processing, we actually have 4 backend services. We have the inventory service, we have a payment service, we have a shipping service, and we have a notification service. So if a user submits an order, we just go through this sequence. We go through validating, going through reserving the inventory here through this service. We go through payment through the payment service. We go through the shipping service, and then we'll go through the notification service here. But here's something to consider. What if one of these services fail? So let's say we go through this process here, we go through the shipping service and the API is down right here. But we've already reserved the stock, we've already charged the credit card. So what would happen here? Well, then we would have to kind of go backward. Now, we're going to just look at the Orchestrator engine, the Saga Orchestrator. This is just a completely generic execution engine, so it doesn't know anything about the order. The most important thing about here is this method right here, the execute Saga. So it's going to actually go through these different steps. And for each step we have here, and these are kind of the orchestration steps that we're going with this order process. It's going to go ahead and perform this execute method. If this execute method works for this orchestration step, then it's going to add onto this list of completed steps right here. So let's see, completed steps here to this list. Now, if any of these steps fail, like we had previously mentioned, if there's some service that's not working, it's actually going to go into this method here called compensate. And right here, any case there's an exception or something that comes up and there's an error, we're actually going to get this list in reverse order. So from what we have so far, from the completed steps, go ahead and go into reverse order. And then from there, we can kind of go from the last one that we had done to the first one to undone. So it will kind of go through that last in, first out principle. So now we're going to kind of look at the orchestrator here. So this is kind of the more concrete implementation, and looking at this specifically in the constructor, this is the kind of the most important part of understanding the different steps. So this is kind of the specific execution order that we're going through this specific list. So we have this kind of constructor injectant to kind of define the specific order of operations that we had. Specifically on that slide we were talking about before, we're going to validate first, go ahead and reserve the inventory here, process the payment, then we're going to create the shipment, then we're going to send the notification, and then once all of these have done and have been executed and there hasn't been any issue, then we're going to go to the last one to complete the order. And so the next thing to look at is this here is going to be the orchestration context. This is the specific map or kind of state that's going to be passed through every step through this Saga. So this is going to have all the information that should be passed through every single step that's going through these different services of validation, reserving, processing payment, creating the shipment. And so, for example, once it's reserved in the inventory step, when they're reserving, it should create this reservation ID. And then once it goes through creating the shipment, it should create a tracking number. And so if anything fails or if anything happens here, it should be able to go back and kind of undo those things. So, for example, if one step fails, then we can kind of go back to the reservation ID to know what context to release. So this is kind of an example of the different keys that are written in accessible run. If any of these kind of mess up, then at least we'll have the shipment ID or payment ID from that reverse order to kind of undo what we had just done through the compensate method. Through here, just to focus on the compensate, this is going to undo any issues that have happened. Let's say, for example, the shipping service or processing, the shipping failed. We need to kind of go backwards and undo all of those steps that happen. So each specific step that occurs, and these steps are basically the steps that are working through completing an order, such as processing the payment, creating the shipment. Each of them have a compensation way that we can undo that specific step, and they're all being called by this method, get compensation, so we're able to go through this. For example, the process payment step, we're able to go here. The execute means we're trying to process the payment. If it failed, we will go through and have this exception, go through compensate. Compensate here will go through the specific steps that have been completed. We get the compensation, meaning that here we would get this method here or this class here that would perform the compensation. And through this, we would try and refund the payment. More specifically, or just looking more deeply, while we're kind of compensating, rolling back on all the specific issues, we do a try catch, meaning that even if one of those steps did fail, for example, we weren't able to refund the payment, we would still have to keep going back, trying to undo all the steps anyway, because before we had the payment, we'd had to reserve the inventory. Maybe we'd had to do another step before that. So we're going to try and log the failure, but we're going to continue with the remaining steps that are available. And through this, we could, in the future, just do more thorough investigation. We could have a batch job to fix those issues, as well as maybe do it manually as well. So this way, nothing is blocked up, and we're able to do our best effort to undo all of those issues or all of those steps that we had already done. So now we're going to run our application. So from here, I'm going to just run it through Podman. We're going to run all the services, such as the payment service, notification service, inventory service, shipping service, and we're also going to run Postgres, Redis, and Zipkin. So from here, we're first going to just like simulate this API orders call. And let me just go back and set this to 0. So give me 1 second. So we're going to just try, once this initializes, we're going to do like a test order here. Once we do this test order, we should get a success here. So everything is completed. If you look at logs here, it just went through all the steps. It has sent a notification. It's completed the order. So all of the things have passed. Everything in the logs look okay. It's gone through the notification service. It's gone through the shipping service. It's gone through the payment service. It's processed the payment. So everything is good here. And so we have in our code, we can simulate some failure. And we're going to set this to 1 here. So we can simulate an error or issue in one of our services. So let's just go ahead and rerun this. And before we were successful in kind of creating our order, but now we will simulate some kind of disaster issue that happens on our application. Like if one of the when the services doesn't work, we can try and run it. From now on, we have a unprocessable entity error. This is because when we went to the payment process, we had modified it within our Docker Compose. So now it's not going to be working. Just to look at the terminal here, we see that once it got to the payment service here, we found the error on the payment processing. It had failed. Since it had failed, like we're going backwards, we're going to start the compensation for the 2 steps that already happened. We're going to release the inventory and we're going to go backwards from there. So to get a better look, we already have this loaded on our application. It's called Zipkin. We're able to kind of get a better idea of the trace. And so from here, since we had that post call, we can kind of go down and see all the services that had gone through. So it was going through that process of validating the inventory, reserving the inventory, and process the payment. But from here, it had errored out. And so it eventually went back, and through that compensation, we were able to delete the reservation that we had prior. So we're able to get the stack trace or look more closely at the trace here through these microservices in Zipkin, but also here through the logs. We're also be able to see where the issue had happened. Specifically, it had failed here. So then it started to run the compensation from that point on. So we can also notice that this one specific trace ID will span across these different services. And so we're able to simplify the debugging that happens here. So here we're going to just take a closer look into the database on this application. We have basically the most important thing is this table here. And this table contains information on the order ID, the status. And the most important one is here, talking about the version. We have this so we can kind of prevent, this is kind of a way we can lock the threads. This is just to prevent if 2 threads are trying to update the same order status. So if we go here into the order state file here, this is just like a locking counter mechanism that is managed by Hibernate. So if they're concurrent updates the same row, if 2 threads are updating the same row, it would fail with this optimistic lock exception instead of overriding the data for the single row. And so from also as well, we're going to just do add a key through redis. We have this redis caching here. And just to show you here, we have redis up. No keys are available here. Once we run this and create the order, we have this key that's saved, this order ID. So in case we want to run this again, and let me just go here. I have the call here. In the off chance we're trying to resubmit with the same key. So, yeah, but for this, so we try to save the order again. It's going to return the same order ID since we already have this within our cache. When we look at the keys here, this key is saved. When we look at our database as well from the order that we had just made, we should see only 2 orders. One with this hash key that's being made if we wanted to create another order without caching, we could just either remove the key here or we could just update the key as well. That way we can return back the same payload as we had before here, without having to go through the services twice. That will just prevent having excessive services run when not necessary. I mean, from here, this is just our front end. Going into the front end folder, we just can run npm install, npm start, and then from here, we're able to have this simple React front end application. So just so we can see, all this does is just place this order here. And then when we check the database here, we should be able to see this order from the customer that's coming in as well. So it's just a very simple React front end. It just sends the request, I believe, and just gets back the response that it's completed, it's been successful. And so we can also just double check if caching is performed. Yeah, we have a different one here. So if it was the same key that was being returned, then it would just go through Redis. It wouldn't go through the database. But this is just a temporary design. It could be expanded. It could be, but this is just kind of like creating the order, getting the order styles